Here's a rational expression that we're going to simplify, and after we simplify, we're going to have something that comes out of the radical, and we're also going to have something that stays underneath the radical. So the first thing I like to do is to split up the radical. Here's a number, 54. I'll put my x's under one radical, and then I'll put my y's under another radical. Now, the square root of 54. I come over here and I look at my perfect squares, and I'm looking to see if 54 is one of them, right? Is 54 a perfect square? No. So do any of these perfect squares go into 54? And here it is, 9. 9 goes into 54. That's 9 times 6. So the square root of 54 is also going to be called the square root of 9 times the square root of 6. The square root of x to the 9th, well, I don't have groups of 2 that are perfect, but I know that I can look at this as x to the 8th, and then x to the 1st, right? That's 9. And I do know the square root of x to the 8th, because I have 4 groups there. And then this y should be y squared. See, I forgot that. I forgot the 2 right there. And then the y squared, well, the square root of y squared, I know what that is. That's just y. Okay, so let's simplify the radicals now. The ones that I know, the square root of 9 is 3. Okay, 6 is still stuck under the radical. The square root of x to the 8th, how many groups of 2? Well, that's x to the 4th. Okay, this x is still left under the radical. And then the square root of y squared is just y. Okay, so I have simplified everything I can. Let's put them all together. On the outside, I have 3 x to the 4th y. And what's left under the radicals is going to be 6 and x. 6x. And that's it.